Hello, this is how to build KDE software for Android AMD64 and run it in Waydroid AMD64. This is the wiki page from the KDE community about Android. We want to build KDE source code. The best option here is to use a container, Linux container, Docker, or Podman. And then inside we will install the KDE build framework Craft. Let's look at the instructions. We will need a terminal and let's start. So in the home directory, I'm on Ubuntu 2504, which is a Linux operating system. In here, I'm going to create a directory craft-kde-android. We're going to follow the procedure. We can choose between Docker or Podman. Podman is easier on Linux because it's just a package that you install. You just go sudo apt install Podman. It's already installed on my computer, whereas Docker, you need to choose, do you want to go with Docker, the Docker community engine from the Docker upstream, or if you want to install the Docker IO package for Ubuntu or Debian in this case. So I'm going to go with Podman. Okay, let's see how we copy the text. Let's see what it does. So it does the following. It's going to create a instance, a Linux container instance that's going to self-destruct. We're going to connect to it interactively. We're going to download this OCI container image from this URL. And once Podman finishes, the container instance will disappear. Why is it no problem that the container instance is so volatile? It's going to just disappear once the podman run command finishes. Is because we're using the directory tilde/craft-kde-android on the Linux host machine, and inside the container this is mapped to tilde/craftroot. This is all that we're interested in, what happens in this directory. The rest can be a cattle style Linux container. No need for a pet Linux container instance. Let's start. So it's going to download the layers for the OCI image. This is a AMD64 image, Linux, based on Ubuntu 2204 with a new Qt version, which is 6.9. Okay, and then we'll be inside this container instance because we have run podman run -ti --rm. This is a volume mapping. The OCI layers have finished downloading. The container image has been created. So on Google, I searched for KDE Wiki Android. KDE Wiki in the sense of community.kde.org, and then the topic Android. And I got to this page, and we're following the chapter build environment option 1. Let's actually see what happened. So we were inside the host computer. Now we're inside the Linux container instance. The user used to be N, now the user is called user. Let's make sure that this directory exists and it's empty. Yes, it's there. Okay, and now we continue installing KDE Craft as usual. There's nothing special to building applications for Android using KDE Craft compared to building applications for Linux using KDE Craft. The difference is what happens in the rest of the operating system that we're installing KDE Craft on. In this case, we're inside a container instance where we have the Android NDK, the Android SDK. We have Qt 6.9 built for cross-building for AMD 64, ARM 64, x86, and ARM v7. The same for the Android NDK and SDK. There's a Java runtime, etc. So everything that's needed to build for Android for 3 CPU architectures is available inside this Linux container instance. And then when we install Craft will determine that we actually want to build for Android because all of those cross-compilation tools and the Qt installed for different versions of Android for different CPU architectures for Android is available. Okay, so there's 4 possible architectures: ARM 64, ARM 32, x86 32, x86 64. And default is ARM 64, so it's prepared to by default build to build Android APK packages that can then be deployed to F-Droid or to Google Play Store and be usable for normal tablets and mobile phones, which usually use this architecture, CPU architecture, ARM64. But we do not want that. We actually want AMD64 because we're going to run the build Android applications on Waydroid AMD64 on this current machine. So this current machine, the host machine is AMD64, Waydroid is AMD64, and the APKs we want them to also be AMD64, such that there's no CPU emulation happening when we build and when we run the application. We want the application to run as fast as possible. And I want to not use an additional Android device. So everything happens on just one computer. So in this case, we want x86_64, which is a synonym to AMD64. Okay, so it doesn't like that. Oh, yes, you don't need to paste this thing, you need to provide an integer, so 3. And for the rest, I'm just keeping the default, so I'm going to press enter. Default yes for colored logs. You can already see that it has detected the Android NDK. And now it's downloading from the KDE Craft cache a ton of pre-built tarballs, and it's archiving them on the current system. Especially it's downloading them and installing them in ~/craftroot, which is a directory that's going to survive even if we restart the Linux container instance. It has downloaded a ton of things, a ton of Qt 6.9 modules, a ton of let's see what it actually did. It has detected Android, it has detected that we want the CLang toolchain for Android, the correct architecture, AMD64 x86_64. So it's downloading a special version of Python, virtual env and other Python modules. Okay, it's great that KDE Craft has been installed successfully, doesn't show any errors. And now that was installing KDE Craft, whenever you want to enter an already installed KDE Craft, you need to run this command if you're using the bash shell. Okay, and now we're inside like this. We're inside, the host operating system is Ubuntu 25.04. Inside we have a Podman instance. Inside we have a KDE Craft build environment. And we'll build the simplest application, KDE application from source that runs on Android devices, and that's Kirigami Gallery. Craft itinerary might be something more complicated because it's using the PIM personal information management libraries. So we want craft search and the name of the KDE Git repository. Okay, so what it's saying is that it could not search because it doesn't have the necessary metadata available. So list of KDE Git repositories that can be built using KDE Craft and the list of KDE source code release tarballs that can be built using KDE Craft. Okay, let's see if it found what we wanted. Nope. Search with minus like this. Okay, so it has found the Kirigami Gallery. This is the correct name. And it's going to build not from Git master branch, which would be this option, but instead it's going to build the newest KDE source code release tarball, which is version 2504.2. And we can see this on this line. So it says latest version 2504.2. The text is a bit confusing, but it wants to say that if we're going to build the module Kirigami Gallery using Craft, it's going to actually build this version. Let's see how it does that. Craft Kirigami minus Gallery. It's going to download pre-built versions of all of the dependencies of Kirigami Gallery. So it depends on OpenSSL, on many Qt 6.9 modules. It depends on many KDE frameworks, a ton of additional Python modules. And finally, the very last thing that it does, after all of the dependencies have been downloaded and installed, so pre-built versions of the dependencies could be found in the KDE Craft cache for Android AMD64, which we can see in here. So Android, CLang, x86-64. This is the URL. There's this cached HTTPS website, https://files.k.org/craft. All of the dependencies could be found, and they're pre-built tar.exe files, which just need to be extracted into tilde/craftroot. But Kirigami Gallery does not exist in the KDE Craft cache. It has done the correct thing, which is download the source code. Again, not from Git master branch or from another Git branch, but from this download tarball, this one. So Kirigami Gallery 2504.2.tar.xz. And then it's building them as usual for a KDE Git repository, which is run cmake configure step with the correct configurations. So special cmake from /opt. A Android NDK. The Linux container instance has its own C++ toolchain, which is Ubuntu 22.04 G++, whereas KDE Craft knows that we want Android AMD64, so it has selected the correct compiler, C++ compiler, clang 17 from this very long directory from /opt/android-sdk. Okay, it has found, cmake configure step has found all of the needed dependencies, many Qt6 modules, a number of KDE frameworks version 6. After the cmake configure step has finished successfully, it has started building using Ninja. 46 C++ translation units to build and other generated files and translations. So this is GNU getText. Or Qt translator. Okay, building has finished, compiling has finished, linking has finished. There's now an executable bin/kirigami to gallery, and then a ton of other binary SO files which are needed in order for kirigami to gallery executable to run correctly, and then maybe additional resources such as icons, icon themes, maybe fonts, other images, etc. Okay, and now it's copying the build files using Ninja install. So this is similar to GNU make install step. Okay, after the Ninja install step has finished, we have many binary files and other files needed scattered around directories in ~/craftroot, which is not what we want. We actually want an APK file that we want to deploy to either a device or to an Android emulator. In our case, we're going to deploy it to the Android emulator Waydroid for the CPU architecture of the host computer. We need to run this command, which will actually generate the APK file. --" package. This is talking about debug symbols. In Linux, when you build an executable or a binary file, such an .so file, you can choose whether to keep the debug symbols inside the binary file, or you can strip them and make the generated binary file smaller and put the debug symbols outside the generated binary file. Okay. So it's generating an APK. There's two steps to it. There's talk about metadata. The generated APK file will be put into tilde/craftroot/tmp directory. And says that it has successfully created the APK file. And the APK file is where? It's hopefully where we want it. So in tilde/craftroot/tmp directory. Using the Java build tool Gradle. Okay. There's an Android manifest.xml file. So let's continue. We want to sign the APK file because otherwise we will not be able to run inside Waydroid. Inside Waydroid, we have the Google applications installed, including the Play Store. So we'll need to sign even if we're using a self-signed certificate. But for that, I'm going to follow these command lines, but in newer versions. I have already proposed a merge request to update these command lines, but meanwhile, I'm going to run them from my notes. This is the wiki pages for my own user and Marius P, under community.kde.org, advanced, Android. So we did this. We have run podman run ti. We're still inside the podman instance. We have installed craft. We're inside the craft environment. We can see that because the bash prompt says craft : we did build Kirigami gallery. We did package Kirigami gallery. Next up, we want to go to the directory where the APK file is. It's this one, extension APK, and name Kirigami2 gallery -x86_64. This command line generates the self-signed certificate in the current directory. The new file is this one, key.keystore. We're using the password 123456 both for the key store and for the key pair that was created. So public private key pair RSA 2048 with this distinguished name. Okay. And now we will need two executables from the Android SDK. One is called zipalign, the other is called APK signer. Let's find this string first. So /opt Android SDK. I'm going to use autocompletion in bash, build tools. There's just one version installed, 35. And then the rest of the command is this one. Zipalign -p -f -v for Kirigami gallery APK, and it's going to generate a file named signed.apk. Ctrl+Shift+V to paste. And it's really fast. Next up, we want the APK signer. So the same thing, /opt Android build tools version, and then APK signer executable. Let's see what it does. So it says sign, be verbose, use the key store that's in the current directory, the file named key.keystore. This will require that I provide the password for the key store, which is 123456. And then I want to use this self-signed certificate to sign the sign.apk file. This is where it asks for the password. Okay, so now we should have two APK files, one with extension APK, another one .sign.apk. And we want to push this sign.apk file to the Android emulator Waydroid. Let's first install Waydroid. I already have it installed, so let's see how that works. I'm searching like this, Waydroid documentation, Waydroid docs. There's install instructions. My operating system is Ubuntu 25.04, so Ubuntu. Debian family of Linux operating systems. I need to run this command. I need to run this one, which will actually create a source inside sources.list.d/etc/apt named a file named waydroid.list that looks the way you would expect. So deb, signature, URL, version, and repo main. Okay, and then you just install Waydroid. It's already installed. It's upgrading Waydroid. Okay, and then you should continue installing Waydroid. Let's see how we do that. We should start the Waydroid graphical user interface application. How you do it is just from the start menu, you write in here Waydroid, and this is it, you run it. Unfortunately, this will run full screen, and I do not want that. I want it to use just half of the screen. So for that, the workaround that I use is that I install Weston. Let's make sure we have the latest updates. Okay. I'm going to start Weston as my current Linux user, so not as the user root. It behaves like a normal window, which means I can resize it. I want it to use half of my screen. And then this is similar to a desktop environment. There's a main panel at the top. There's a clock. And there's a pinned icon, which is the terminal. I'm going to start the terminal. And in here, I need to run this command. Unfortunately, copy paste does not work. Paste. Okay. So I'm going to write the command line by hand. Waydroid show full UI. This thing. It has found that I have already run Waydroid before. Otherwise, it would need to install the two OTA image Android files and then boot the Android system inside a LXC Linux container. But since I have run Waydroid before, the image is already available, and also the container was already running. Okay. And now we want to push the sign.apk file to the Android emulator. So inside console, which is a terminal emulator, we have the first tab with inside Podman inside Craft, the second tab with inside Weston inside Waydroid, inside Weston, and on the third tab we're going to be inside the host operating system, where we're going to change to the correct directory, which is not ~craft root, but ~craft KDE Android, which is the directory, that's the volume that's exposed inside the Docker, inside the Podman Linux container as ~craft root. And then the temp directory. I should have the same contents as inside the container. So the same directory, exactly, it's present both inside the Podman container and inside the host operating system, but at different directories. Okay, let's just copy this entire line. So Waydroid similar to the Git command line has verb, so app is a verb, and then what install subcommands. It's going to take the sign.apk file, this one from the current directory, copy it over a channel, I'm not exactly sure what, ADB or something else, towards the running Android instance. Okay, let's go to Waydroid. Because I have Google Apps installed, it also has Google Play Protect. Once Waydroid command line tool has told Android, hey, here is an APK for you, please install it, with something similar to the ADB debugger tool. Google Play Protect has received the application and is going to make sure it's not that malicious. I'm not exactly sure if it can detect all of the possible ways in which an Android app can be malicious. I need to choose Scan App. And then I need to choose Install. And now the application should be installed. It's not available on the home screen, of course, but it's available in the list of all applications. Drag from the bottom, and the application is this one, Kirigami Gallery. Single click, and this is it. It's a Android application, AMD64, Qt 6.9, QML, QQuick Controls 2, and it's using the graphical user interface framework for QML QQuick Controls 2 from the KDE community that's named Kirigami. And this is the Kirigami QML components or items. There's buttons, there's bottom drawer, this thing. there's a sheet which is similar to a modal dialog. Close. Passive notification, similar to a notification, comes from the bottom. A notification with button. It's showing the controls at the bottom this time. I'm not exactly sure what the rules are. When the equivalent of the main toolbar is positioned at the top of the window or at the bottom of the window. Certainly on mobile phones with a very limited resolution, you want everything to be at the bottom of the screen because that's where your right thumb is. Okay. What else do we have? Dialogues. Modal dialog. Okay. Dialog with an edit box. The on-screen keyboard, Android on-screen keyboard works. The enter button works. Create folder. I can scroll through the dialog with the scroll wheel on my mouse. A finger is not emulated with my mouse inside Waydroid. So I actually must use the scroll bar. When I click on a position inside the scroll bar, the scroll bar jumps there. I cannot prove that there's a context menu for the scroll bar. So long press doesn't do anything. Right click mouse doesn't do anything. This is the radio button, so single selection. Close. So a message box without the close button. A complex message box. The UI reflows, so similar to a grid layout. Depending probably also on the screen resolution. Progress bars. Slider. You cannot keep your finger down to move the slider. Just left mouse button down puts the slider at that position. Slider with 2 positions. In here you need to select the button that you want to move and then click. So click once, click twice. So this is similar to newspaper articles, cards. Okay, so this is just showing the fact that we could get a KDE Git repository, which is named Kirigami Gallery. Let's actually find it. Let's see how we can find that thing. Okay, so this one, invent.k.org/sdk/kirigami gallery. we're actually building a release tarball, not the Git branch, but still we're building it from source. I'm not sure how to resize this thing. Like this. Okay. We have downloaded a source code release tarball of Kirigami Gallery, extracted here using the KDE build framework craft. We needed a special build environment because we need Android NDK, a certain version, to be installed for 4 CPU architectures, then a certain version of the Android SDK, which contains a correct version of LLVM CLang C++ compiler, a special version of CMake. Then we needed a special version of Qt 6.9 for Android built using those 4 CPU architectures. So all of that is made available by the combination of a pre-built OCI container provided by the KDE community. This one, KDE invent-registry.kde.org/ci-images/android-qt69 plus the KDE build framework KDE craft that is being used by the GitLab CI that KDE uses, that is building automatically merge requests, compiling them, so certain KDE Git repositories using KDE craft, using GitLab CI, will be built for Android ARM64, for Windows, Microsoft Visual Studio 2022, and for other targets. So KDE Craft can also be used for building Linux AMD64 app images. So this is it. This is how on a Linux operating system you can build the source code from a KDE Git repository or from a source code release tarball from a KDE repository, build a valid Android APK out of it, and then test, make sure that the Android application runs correctly with the best speed possible, and that's, I say, not on an Android. If you want the best possible run speed and installation speed, you probably don't want to use an Android device, but you want to use an Android emulator, such as the Android emulator inside the integrated development environment Android Studio or Waydroid. But then if you run the Android application on a real Android device, you will get a complete run environment. You will get Android additional sensors, Android gyroscope, all of the other sensors, webcam, microphone, the correct Android sleep behavior. So this is it. I would encourage you to develop for KDE and for Android to improve the support that KDE applications have for Android, and this is a way to do it. Thank you.